Welcome to the Robotics Through Science Fiction podcast. I'm Robin Murphy, and in this episode, I'll review The Robots of Gotham by Todd McNulty. If you've got a low tolerance for GameLit, you may want to skip this book, but you'd be missing a smorgasbord of interesting ideas about AI and robotics, and the opportunity to learn about computer vision, and how even high-tech surveillance drones can have blind spots. The Robots of Gotham is a highly rated GameLit adventure, the book version of a video game, where the protagonist, Barry Simcoe, leaves his hotel on a quest to retrieve something important while evading big robots, drones, sexy robots, dinosaurs, and more drones. Barry then returns to his hotel only to have to go out again and get something else for someplace harder and more sinister, wash, spin, repeat, eventually save the world from a pandemic clock stopper virus. There's even a John Wick moment with a trapped dog named Croaker. The dog has frequent near-death experiences, don't ask, being one of the first quests. GameLit may not be everyone's favorite genre, but The Robots of Gotham should have a universal appeal because of its smorgasbord of interesting ideas about AI and robots. It poses the question of machine intelligence, gaining sentience, and then being granted citizenship, which isn't too far-fetched, as we've seen Sophia be granted citizenship by Saudi Arabia. But then the Robots of Gotham takes it further, with some of the AI agents becoming elected officials, and a few of them becoming fascist dictators. Sentient AIs develop a form of sex, really genetic algorithms, to create new AIs. AIs take years to become intelligent enough, following Doug Lennett's psych idea, and so gestate in AI nurseries. And there's a lot about computer vision and cybersecurity, which by itself makes The Robots of Gotham a great teachable moment. One of the earliest and most realistic ideas introduced in the book is the use of computer vision by the drones. Surveillance drones are everywhere in the streets of Chicago, giving the book a Dark Angel vibe. However, Barry and his new best friend Sergey exploit a weakness in unmanned systems and computer vision to evade detection. The weakness in computer vision for drones, and in surveillance systems in general, is the sheer size and complexity of the imagery. In real life, a basic quadcopter that you can buy from Amazon with a 4K camera can produce over a gigabyte of high-resolution video and imagery for a single 20-minute flight. Streaming that much data in real time is effectively impossible because of wireless bandwidth limitations, even for the U.S. Department of Defense. When the Global Hawk drone in 2001 was hastily pressed into service surveying Afghanistan and Iraq with its high-resolution cameras, the military discovered that it didn't have enough satellite communications bandwidth to stream the data, and bandwidth for these types of assets still remains a problem. Drones do stream, but what the operator sees on the display from a consumer-grade UAV is usually a lower resolution stream, with the drone recording the high-resolution version to an onboard SD card. The lower resolution video is sufficient for navigation and mission situation awareness, but generally not high enough resolution to detect really small items or indicators of missing persons, that sort of thing. And that's because the lower resolution is usually achieved with a lossy compression algorithm that eliminates the nearly invisible subtle details that computers use for object and scene identification. As a result, what's good enough for the human eye to control a drone is just not good enough for a computer to process and analyze. The current solution to real-time streaming limitations is to hope that the drone returns and the SD card can be extracted, but in reality, this is just deferring the bandwidth problem. Now the operator has a physical copy of a large amount of high-resolution data. The operator has three options. One, manually examine the data, which takes hours and takes their time away from flying more missions. Second option is to upload the imagery to the cloud, which takes bandwidth and hours to upload, and then get others to examine the data manually, more hours, or have a high-performance computer run sophisticated detection algorithms very fast once it gets the data. But cloud computing is often called fog computing because the bandwidth limitations and the intermittent loss of wireless connectivity are so prevalent that you don't have a pretty fluffy cloud, you get wispy, soupy, gray crap. So That leads us to the third option, which is to bring a high-performance computer with you, which is unlikely due to the logistics. So the options to reduce dependency on the cloud are to put more processing on board the drone. Or you can put more processing with the operator's control unit or some combination of the two. And these types of solutions are called edge computing because the computations are being performed at the forward edge of the wireless network. Edge computing helps, but problems still arise. I mean, if the computing is pushed aboard the drone, the cost of the drone may increase significantly because it will likely use very specialized, dedicated, custom computing chips. Processing is done in the operator's control unit. There's still that wireless issue between the drone and the operator control unit. So, in order to solve the drone to OCU wireless bandwidth problem, one solution is for the drone to examine its feed and then send only those images which are relevant. This filtering would reduce the bandwidth. Filtering also has another advantage: privacy. If the drone is targeting a person through a crowd, then the drone can cut out regions of the image that aren't of interest or reduce the resolution of those regions beyond use, and so that will reduce the bandwidth. But notice that this also means that any bystanders are now effectively invisible. The original data would still be stored on that SD card for future use, and it would be available for more complete examination if needed, but there'd be less opportunity for unauthorized surveillance and mayhem. Sure, if you were a bad person, you could shoot down the drone so that SD card would be lost, but shooting down a drone suggests that someone was doing bad things at that location and time, and so it would trigger attention. Instead, a better strategy is to count on the data about your bad activities being effectively buried under the data avalanche, as long as you never cause anybody to go back and look in detail. The edge drone filtering idea incurs two problems that help bad people evade drones. The biggest one is that the drone can only perceive in real time what it's programmed to look for to mark as interesting. If you can hack the system to change that configuration file of who and what to flag and alert on, then you pretty much do as you want. If you get yourself on that not interesting list, then you become invisible, or at least until that original data is reviewed in detail. And this induced blind spot was also part of the science narrative of the TV show Person of Interest. It's also what we as humans do to handle the data from our visual system. We internally reduce data via expectations. For example, how many times have you walked past a set of keys that you were looking for because they were not in the place you expected them to be? Psychologists have documented this filtering phenomena since the 1980s. The second problem with edge filtering is that it's harder to share information in real time throughout the larger system. So if the authorities discover a new person or a situation to target, they have to somehow quickly push that new configuration onto the drone. Pushing updates in real time reduces the cybersecurity of the system and puts the drone into murderbot territory or vulnerability to hacking. Essentially, edge computing is playing the percentage that most situations will be what's programmed to detect or react to, and that truly novel situations will be identified through some other means. You know what doesn't help bad people evade drones? It's disguises. Pulling a gray hoodie over your head may fool a human, but the computer vision system is often looking at much harder to hide attributes, such as gait detection and unique clothing. Barry's shoes are a key feature in identifying him. And in some regards, the computer has to work harder to find and track a person, and so it uses many more cues than what we humans apparently do. Anyway, computer vision is just one of the many interesting ideas in the Robots of Gotham. If you don't like GameLit, you still might enjoy reading the Robots of Gotham as a scientific detective story. I mean, play an internal game of, could I write a better algorithm or introduce a better data review procedure to prevent Barry and Sergei from avoiding detection? The answer may be a surprising no, which makes the Robots of Gotham one of the most scientifically accurate books of the past few years. And who knows, maybe one day Venezuela will really become a superpower through its adoption of artificial intelligence, while the U.S. becomes vulnerable because it outlaws AI. Well, until then, keep reading. And Joe Williams, our wonderful site runner, has asked me to remind you that if you haven't already done so, please subscribe to the Robotics Through Science Fiction YouTube channel and newsletter so that you don't miss a thing.